In part 1 video, we have done some one-dimensional problems. In this video, I'm going to do a couple of two-dimensional problems. A motorboat traveling 4 meters per second east relative to a river encounters a current traveling 7 meters per second north. What is the resultant velocity of the motorboat? I'll start with directions. Okay. Up is north, down is south, right is east, and left is west. I'll draw the river. It's flowing towards north. That's the direction of velocity of the river. Velocity of river with respect to the ground. VRG, 7 meters per second north. A motorboat is trying to cross the river. It's moving towards east. That is towards right. With a velocity of 4 meters per second. Velocity of boat with respect to river is 4 meters per second. We need to find the resultant velocity of the motorboat. Okay, so we have two vectors here. I'm going to find the resultant of these two vectors. So I'm going to move this vector. I'm going to place it here. Okay. Now we have two vectors. Tail, head. Tail, head. So this is the starting point and this is the ending point. So the resultant vector should be from the starting point all the way to the ending point. That is my resultant vector. I'm going to draw that. From the starting point all the way to the ending point. This is my resultant vector. How do you find the resultant of these two vectors? This is the equation of relative motion. Velocity of an object relative to a reference frame, a moving reference frame, is equal to velocity of object with respect to ground minus velocity of moving reference frame with respect to ground. These are vectors. So velocity of object with respect to ground is equal to velocity of object with respect to moving reference frame plus velocity of moving reference frame with respect to ground. In our problem, boat is the object. Object is boat or B. So we will replace O with B, and moving reference frame is river. So we will replace M with R. Ground is ground. Okay. So V, object is boat. VBG equals object is boat, moving reference frame is river plus velocity of RG. Same as the picture, VBR plus VRG should give us the resultant, which is VBG. We have VBR here and VRG here. The resultant is velocity of boat with respect to ground. How do you find that? How do you find the resultant? This is a right triangle, so you can apply Pythagorean theorem to find the magnitude of the resultant. VBG equals square root of VBR square plus VRG square. VBG square root of 4 square plus 7 square. 8.06 meter per second. I'll try to explain the meaning of this problem. A river is flowing north with a velocity of 7 meters per second, and a boat is trying to cross the river. It's trying to go exactly east. Because of this current, for an observer standing on the ground, he could see the boat moving in this particular direction. What is the direction of this vector? Theta equals tan inverse y component over x component. Y component is VRG, so theta equals tan inverse VRG over VBR. Theta equals tan inverse 7 over 4, 60 degrees. For an observer on the ground, boat is moving with a velocity of 8.06 meter per second at an angle of 60 degrees from the east. Let's do another one. Example 3.3, airplane in a crosswind. Airplanes move relative to the air that surrounds them. Suppose a pilot points his plane in the northeast direction. The airplane moves with a speed of 160 meter per second relative to the wind, and the wind is blowing at 32 meter per second in a direction east to west. What is the velocity vector of the airplane relative to the ground? How far off course does the wind blow this plane in 2 hours? Another two-dimensional problem. An airplane is moving in the northeast direction. It's moving with a speed of 160 meter per second relative to the wind. Okay, in this problem, object is plane. Moving reference frame is wind. Ground is ground. We will replace O with P and M with W. Ground is ground, G. Equation is velocity of an object with respect to a moving reference frame is equal to velocity of object with respect to ground minus velocity of moving reference frame with respect to ground. So how do you write the equation for VOG, velocity of object with respect to ground? VOM plus VMG. Okay, let's replace O with P. So VPG equals VPW plus VWG. We're going to use this equation. Okay, let's draw the picture. Okay, direction is always up is north, down is south, right is east, and left is west. The direction of airplane is northeast. This is the coordinate system. Airplane is moving in the northeast direction. This is north, this is east. Northeast vector should be exactly in the middle of these two axes. So this angle is 45 degrees. This is velocity of plane with respect to wind. That is 160 meter per second. Wind is blowing from east to west with a velocity of 32 meter per second. Velocity of wind, this is with respect to ground, 32 meter per second. And we need to find VPG, velocity of plane with respect to ground. What is the velocity vector of the airplane related to the ground? So we need to find VPG. This equation shows VPG is the resultant of these two vectors. So tail, head, tail, head. The resultant should be from the starting point to the ending point. So that's the resultant, VPG. If this angle is 45 degrees, this angle is also 45 degrees. So you can use law of cosines, which is resultant equals vector A square plus vector B square minus 2AB cos theta, where theta is 45 degrees in this question. R equals square root of 160 square plus 32 square minus 2 times 160 times 32 times cos 45, 139.2 meter per second. Let's solve it in a different way. Okay, we have two vectors, VPW. So this is VPW, right? This is VPW, velocity of plane with respect to wind. This vector is on xy plane. So I'm going to find the components of this vector. I'm going to draw the components. This is x component, VPW x. This is the x component and this is the y component. That's how you draw the components, VPW. And this angle is 45 degrees. So how do you find the x component? X component is touching the angle. So VPW x is equal to the main vector, which is VPW cos theta, cos 45. VPW is 160. VPW is 160 meter per second. Velocity of plane with respect to wind is 160 cos 45. I'll draw a table. Vectors x component, y component. First vector is VPW, and the second vector is VWG, At the end, we will find the resultant vector, which is VPG. Resultant vector is VPG. Okay, so what's the answer for this? 160 cos 45, 113.13 meter per second. What is VPWY? Y component of this vector. VPW sine 45. 160 sine 45. You'll get the same answer, 113.13 meter per second. So x component is 113 meter per second. This is also 113 meter per second. Both these vectors are positive because x component is towards right and y component is towards up. So both of them are positive. Now let's find the components of our second vector, VWG. Velocity of wind with respect to ground. So it's towards left. This is VWG. You don't need to calculate anything. It's already on negative x-axis. So y component is 0. There is no y component for this, 0 meter per second. You cannot draw y component here, right? And what about the x component? It's same as VWG. VWGX component is same as VWG, but the direction is towards left. So you should put a negative sign. Minus 32 meter per second. Now let's add the x components and y components together to find the resultant vector, which is VPG. Y component should be 113 plus 0, which is 113 meter per second. And x component will be 113 plus minus 32, 81 meter per second. So VPG, the resultant vector, is equal to 81 x cap plus 113 y cap. How do you find the magnitude of this vector? This is a vector, right? How do you find the magnitude? Square root of x component square plus y component square. You'll get the same answer, 139.03. To find the angle, to find the direction, theta equals tan inverse y component over x component. VPGY over VPGX. Y component is 113, so tan inverse 113 over 81, that is 54.37 degrees. Now let's find the course deviation due to wind. The pilot tried to direct the plane at an angle of 45 degrees, that is in the northeast direction. This is velocity of wind with respect to ground, that is 32 meter per second. Because of the wind, the direction has changed. So this is the deviation. This is the deviation. Velocity is 32 meter per second. Time is 2 hours. How to find the distance? Equation for velocity is displacement over time. Or displacement equals velocity into time. Velocity of wind, which is 32 times t. T is the time, which is 2 hours. We need to convert 2 hours into seconds. So 2 hours, that is 2 times. In 1 hour, we have 60 minutes. And 1 minute, we have 60 seconds. 60 times 2, which is 7,200 seconds. Substitute back here, 7,200 times 32, 230,400 meters or 230.4 kilometers.